For over 4 billion years, Earth has been a sanctuary. A pale blue dot adrift in a sea of black. It has survived asteroid strikes, mass extinctions, ice ages, and magnetic reversals. But nothing lasts forever, not even Earth. When we talk about the end of Earth, we often picture cataclysmic events. Asteroids, supervolcanoes, climate disasters. And while some of those threats are real and imminent, others lie far in the future. Threats that come not from within, but from the cosmos itself. This is not fiction. These are projections rooted in science. From the journals of NASA, to the labs of MIT, to studies led by planetary physicists at institutes like Caltech and the Max Planck Institute. In this documentary, we're not just imagining how the world might end. We're following the roadmap scientists have already begun to piece together. This is the timeline of Earth's inevitable demise and the strange, beautiful, terrifying events that will lead us there. In 2013, a 20-meter meteor exploded over Russia with the energy of 30 Hiroshima bombs. It injured over 1,500 people. That rock was never seen coming. According to NASA's Near-Earth Object Program, over 27,000 asteroids currently orbit dangerously close to our planet.
NASA has an extensive near-Earth observation program that's been scanning the skies for well over a decade to catalog the most potentially hazardous asteroids and to assess their impact threat.
Of those, more than 2,200 are classified as potentially hazardous asteroids, meaning they're large enough and close enough to cause regional or even global catastrophe. Astronomer Dr. Amy Maynor, lead investigator for NASA's NEO surveyor mission, said, "The question is not if an asteroid will hit Earth again, but when." The threat of impact may be low statistically, but the consequences are so severe, even a 1% risk is taken seriously. Just 66 million years ago, an asteroid 10 kilometers wide wiped out the dinosaurs. If a similar object struck today, the result would be an extinction-level event. Then there's what's beneath our feet. Supervolcanoes. The Yellowstone caldera in Wyoming is one of the most closely monitored volcanic systems on Earth. If it erupts again at full power, as it has roughly every 600,000 years, it could bury large parts of the United States under ash, drop global temperatures, and destroy agriculture for years. Scientists from the US Geological Survey estimate a super eruption could lead to a volcanic winter. A scenario where sunlight is blocked for years, ecosystems collapse, and billions could face starvation. These are not hypothetical events. Both asteroid impacts and supervolcanic eruptions have happened before, and they will happen again. Earth has a hidden protector, its magnetic field. Generated by the motion of molten iron in the planet's core, this magnetic shield deflects solar radiation and protects our atmosphere from the solar wind. But this shield is weakening. Measurements over the last century show a significant drop in field strength, particularly over the South Atlantic Anomaly, a region stretching from South America to Southern Africa. According to research from the European Space Agency's swarm satellites, Earth's magnetic field has weakened by 9% in just the last 200 years. That's fast in geological terms. More worrying is the potential for a pole reversal, magnetic reversals, where north becomes south and vice versa. These have occurred many times in Earth's past. The last one happened about 780,000 years ago. During a reversal, the magnetic field can drop to 10% of its current strength, or disappear entirely for centuries. Without it, Earth's atmosphere could be stripped by the sun's radiation. Dr. Gary Glatzmir, geophysicist at UC Santa Cruz, warns us of the dangers. If we were to lose our magnetic field even temporarily, it would be catastrophic. The sun would erode our atmosphere. Life on the surface could become impossible. While a reversal wouldn't kill Earth, it could kill everything that depends on Earth's stable surface conditions. Us. Of all the threats Earth faces, the most certain is also the most distant. It lies at the center of our solar system, the sun. Right now, the sun is a main sequence star, calmly converting hydrogen into helium through nuclear fusion. But this balance won't last. In roughly 5 billion years, the sun will begin to die. As it exhausts its hydrogen fuel, fusion will slow. The sun's core will contract under gravity, heating the surrounding layers and causing the outer shell to expand. This is the beginning of its red giant phase. According to astrophysicist Brian Cox, the sun will swell to over 100 times its current diameter. Mercury and Venus will be engulfed. Earth might survive the expansion physically, but it will not escape the heat. As the sun grows, Earth's oceans will boil. The atmosphere will be stripped away. The surface temperature could rise above 2000 degrees Celsius, hot enough to melt rock. New studies from NASA's Goddard Institute suggest that even 1 billion years from now, long before the sun becomes a red giant, the increasing solar luminosity will make Earth uninhabitable. A slow and steady extinction. Eventually, Earth may spiral into the sun and be consumed, or it may be flung outward into the cold void, depending on how much mass the sun loses during its expansion. Either way, this is the final act. The star that gave us life will become our executioner. Long before the sun swallows us whole, life on Earth will suffocate. With the sun growing hotter each century, more energy will reach Earth. The runaway greenhouse effect, similar to what happened on Venus, becomes inevitable. Dr. James Casting, a planetary climatologist at Penn State, has modelled this transformation. He explains that as the temperature rises, more water vapour enters the atmosphere. Water vapour is a greenhouse gas. It traps more heat, causing more evaporation, a feedback loop that ends in disaster. Eventually, Earth's oceans will vanish into the sky. The stratosphere will become saturated with water, and solar UV rays will split the H2O into hydrogen and oxygen. The hydrogen will escape into space, and that will be it. No water, no atmosphere, no protection. Earth will be a barren desert world with a thin, toxic sky. Think of Mars, but with scars of a once living world still visible. Fossilized skeletons of civilization buried beneath layers of scorched dust. Even if Earth somehow survived the sun's expansion, or we relocated humanity to another star system, the universe itself holds darker, more random threats. One such danger is gamma-ray bursts, GRBs. These are among the most powerful events in the cosmos. They occur when massive stars collapse or when neutron stars merge. In a matter of seconds, they release more energy than our sun will emit over its 10 billion year life. If a gamma-ray burst were aimed at Earth from even 10,000 light years away, it could strip away our ozone layer, boil the atmosphere, and fry the surface in radiation. In a 2005 study, astrophysicist Dr. Adrian Mellott proposed that a gamma-ray burst might have been responsible for the Ordovician mass extinction over 400 million years ago. The evidence? A sudden drop in biodiversity and signs of ozone loss. Then there are rogue stars and wandering black holes, invisible predators drifting through interstellar space. Their paths are random, their existence is real. The Gaia spacecraft has already mapped over a dozen rogue stars on trajectories that could bring them near our system in the next few million years. And finally, galactic fate. In about 4.5 billion years, the Milky Way will collide with the Andromeda Galaxy. Stars will not smash together, but gravitational chaos will ensue. Our sun may be flung into deep space. Earth, if it still exists, could become a frozen exile. The universe doesn't need to try to kill us. Its natural processes are enough. Now let's go farther than Earth, farther than the sun. Let's go to the end of the universe itself. According to the most widely accepted model in cosmology, known as heat death, or the Big Freeze, the universe will continue expanding forever. Galaxies will drift apart, new stars will cease to form, existing stars will die, and black holes will evaporate via Hawking radiation. In a trillion years, all that remains will be cold matter and background radiation, slowly fading into nothing. Dr. Katie Mack, theoretical astrophysicist and author of The End of Everything, puts it best. Eventually, the universe reaches a point where nothing new happens. No stars, no fusion, no structure. Just entropy at maximum. A silent, dark eternity. By then, Earth will have long ceased to exist. But even if it hadn't, there will be no sun to warm it, no sky, no light, no memory. Earth's end in the grandest scale is not an explosion. It is a fading into silence. This might all sound bleak, and it is. The death of Earth, like all things, is inevitable. But the gift of knowing this is that we are here now. We have air to breathe, oceans to cross, skies to watch. One day, everything will end. But until then, we live in a rare window, a moment of balance in a universe that doesn't care if we exist or not. Maybe the point isn't to survive forever. Maybe the point is to understand, to witness, to protect what we can while we still can. Because in the end, Earth won't die in violence, it will die in silence. And in that silence, the only thing that will matter is what we did with the time we had.